Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and tonight I'm joined by Sana Withers, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. Just a reminder, this is, once again, Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Western Worlds, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or about Tuesday morning at 2 a.m. Universal time, if that's your jam. The York Universe production works in concert with our online public viewing program run by our amazing observatory team. Go team! That is running at this exact same time. So that means 9 to 10 p.m. local Toronto time. If you're listening live, go on over to the YouTube channel or YouTube York Allan Carswell Observatory. You can also get there by following our website links. That's yorku.ca/science/observatory, and follow the links to OPV online public viewing, or click any of the links that say YouTube and it'll take you there. So it is a great show. Lots of people there to answer your questions. And if the sky is clear, we might get some live viewing, but I don't think they're going to tonight. Just a reminder, our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. If you have any questions or comments about our past shows or suggestions for future topics, please email us at observe@yorku.ca. And as the show is going on, you can always connect with us over on Twitter with @York Observatory, or actually York Universe as well, and on Instagram with York U Observatory, Facebook, Allan Carswell Obs, and of course over on YouTube, as I mentioned before. All of our programs are free, but if you'd like to make a donation, you can head on over to that website, yorku.ca/science/observatory. Our amazing observatory crew will be monitoring the YouTube chat for questions and posting content like beautiful archival images of space and planets and wonderful things. The current weather has been absolutely terrible. We had a few little moments of clearing, and it looks like it's going to start raining again. How is it over where you are, Sana?
It is terrible. It's just been like rain for the past week, unfortunately.
I actually did see the sun today for a few moments. I sort of remember looking up and seeing completely black clouds on the left and blue sky on the right, and thinking, must be springtime.
Yeah, about typical for Toronto this this time of year.
Yes, I am learning.
Yeah, it was like 2 weeks ago. We were getting like high 20-degree weather, near 30 degrees for a couple of days, and then it's just back to this now.
Well, yeah, and there was that real high. We had 30, and then we had a hailstorm and a snowstorm, and then now we're raining. So I guess, yeah, this seems about right for Toronto.
Yeah.
Thank goodness we have beautiful new domes on the observatory, which we just actually inspected today, if anyone's really curious. They still do not leak. So there's that.
Yeah, I remember every time it used to rain, even when I was at home, I'd get a little worried thinking like, are we getting any rain on the telescopes? But don't have to worry about that anymore.
Well, there's a strange software that's happening now where we are occasionally getting it to accidentally close the domes, but so far, knock on everything you can find, nothing has caused it to open spontaneously. So we're doing very well over at the observatory. We're very excited because a lot of renovations are going on, of course. And if we were to try to escape, of course, all this rainy weather, one option might be to go into space. We might not get there, but Sana, I think you've got a nice segue for space and astronomy history. How to avoid rainy weather?
Just go above the clouds. I wish it was that simple, but yeah. So the first This Week in History item is May 6, 1975, which is when NASA announced that Canada would be building what's now known as the Canadarm for the Space Shuttle program. So the Space Shuttle program it did have some international partners along with NASA who was in charge of the program, and Canada was one of them. And one of its contributions, or its primary contribution, I think, to the Space Shuttle program was creating what NASA has called this glorified crane, basically, that was primarily designed to deploy cargo that was in the Space Shuttle cargo bay and bring it out of that cargo bay to further deploy it into space. And the way the Canadarm is designed is it's basically kind of designed after a human arm. So it has a shoulder, a elbow, and a wrist. And then it has several joints in each of those areas, which allows it to kind of move around just like a human arm and pick things up and move them around in space, which of course you need to do when you have something like the Space Shuttle. So following the announcement in 1975, it took a few years for Canada to develop the Canadarm, and then it finally flew for the first time on November 13th, 1981. It flew It flew through most of the Space Shuttle missions over several years. And the first mission was on STS-2, which was the second flight of the Space Shuttle program, which is primarily designed as a kind of test flight for the Canadarm to test out how it works and how it operates in space if it operates properly. So over the years that it operated, it did a whole lot of different things. It primarily, like I said, was responsible for deploying things out of the cargo bay of the Space Shuttle. A couple interesting missions that it deployed was the Compton Gamma Ray Observatory and also the Hubble Space Telescope in 1990. But of course, it also deployed a lot of other things like other communication satellites and even some classified military satellites that were deployed through the Space Shuttle as well. On top of that, it ended up being used for a bunch of other really important things in space that was kind of beyond what it was maybe originally designed to do, deploying cargo out of the cargo bay, which included some troubleshooting, like knocking ice off of the side of the Space Shuttle. It was also used to retrieve satellites so astronauts could repair them. And after the Columbia Space Shuttle disaster, Canadarm was upgraded to include a lot of cameras that it could use to inspect the outside of the Space Shuttle to make sure that it was safe for re-entry and landing. And one of the really important things that the Canadarm ended up doing over quite an extended period of time was it helped to assemble the International Space Station. So there were quite a few times where after some components of the International Space Station were launched, that the Space Shuttle would dock to that and then use the Canadarm to assemble different components and sort of snap them together. So it was, of course, a very, very important piece of technology that was used to do a lot of very important things in space. And on top of all of that, it was also important from a different perspective, which was developing the kind of technology to be able to do things like this, because it was the first kind of real robotics that was used in space. So it required a lot of new kind of developments and a lot of new technology to be able to even build something like that really paved the way for a lot of the space robotics that we see today. It also helped to solidify Canada's role as being good at dealing with these kinds of space robotics. And Canada has continued to build Canadarms and things like that for the International Space Station. So this includes the Canadarm2 that was installed on the ISS in 2001. And then a few years later in 2008, Canada installed what's called Dexter on the outside of the International Space Station, which is the most advanced space robot ever built. This thing is really cool. It has a lot more freedom than Canadarm and can do a lot more complex things. It even has a sense of touch to it, which is kind of wild. It has a lot of pressure sensors, so it can deal with very sensitive equipment and very sensitive procedures that the Canadarm itself might not fully be able to do safely. So Canadarm and Dexter sort of work together now on the International Space Station to do a lot of these maintenance and repair things that are really important to keep the space station up and running properly. And of course, Canada is also developing what's called the Canadarm3, which will hopefully be used on the upcoming Artemis missions. So Canada has definitely kind of taken a lead on all of these space robotics things, which all started with the Canadarm back in 1975 with this announcement. And just before I finish up this little piece of this week in space and astronomy history, you can see the Canadarms if you go to the right place. There were 5 of them that were built in total. One of them was unfortunately lost in the Challenger accident. One of them was taken and used for some sort of testing after it was finished being used. But the other 3 Canadarms are in museums. There's one of them in Ottawa, one of them in DC, and then one of them in Virginia. So I think it's pretty cool. You can actually go and see one of the Canadarms that helped to assemble the ISS.
That is very, very cool.
Mm-hmm.
And of course, it's just so awesome because it's like Canada literally giving space a helping hand.
Yeah. It's one of those like smaller things that probably not many people think of. Like when you think of the International Space Station, most people probably don't think of the Canadarm 2 that's on the International Space Station right off the top of their heads, but it really is like a critical piece of equipment that's on the ISS that Canada.
Oh yeah, well, I mean, you literally could not have put it together without that.
Mm-hmm.
So, I mean, it sounds amazing. I wish we had one. This awesome robotic arm that you could just sort of maneuver all around your observatory and knocks nice ice off. And I mean, if it was for our observatory, we'd have to get it to chase away birds as well, but.
But we wouldn't have to deal with the climbing up on the roof ever again.
Yeah, exactly. Just one really cool robotic arm that could completely prevent me from ever going up on the roof again. And it is really interesting to see what they're going to end up doing with Canadarm3 and the improvements that they're thinking about making. And on the way to Artemis 3, of course, we still have Artemis 2, because we can't say Canada and space without saying that we're literally getting another Canadian astronaut getting sent up in actual Artemis 2. Of course, Jeremy Hansen made all the news a little bit ago. He's one of the 4 together with Christina Koch, Victor Glover, and Reed Weissman, who are going up in Artemis 2 before Artemis 3 ever goes. And I don't think they're getting a Canada arm, but they won't need one because they're not landing.
Yeah.
But really, really exciting stuff, and I love the technology behind it and how it's developed with robotics. Because of course, one of the things that people like to mention when they talk about how does space benefit humans on Earth, right? How does space travel and going into space and doing all this space stuff? How does it directly benefit humans on Earth? And I always think of artificial limbs, because a lot of artificial limb development and technology has actually come about through space missions. And I mean, you look at Canadarm and you're like, wow, okay, that's really advanced. I mean, I wouldn't want that many joints in my arm, but I really appreciate the high precision and technology behind it. So it's one of the also one of the many sort of direct benefits that we get from space travel. So, Hooray! All right, so let's see, where are we up to now? Oh, it's my turn. So I have a little bit of a different one. So I was going to try to make it all space themed, and I've sort of succeeded, because we've been talking about, of course, with Canadarm and NASA going into space, but humans have wanted to go into space for a long time, and we've been curious about the moon forever. So I just have to go back to a really fun, interesting little bit of history. And May the 4th is coming up, very shortly. Today's May the 1st. And May the 4th has actually become somewhat of a commercial holiday in recent times, since 1977, when Star Wars came out, because it nearly matches up with one of the lines from Star Wars. So people would say, "May the 4th be with you." It was an actual marketing thing, very science fiction, very space. But May the 4th, actually coming up recently, back in 1783, had its own little space tie-in, space exploration tie-in. May the 4th, 1783, so a long, long time ago, not in a galaxy far away, here on Earth, William Herschel reported seeing a very unusual thing happening on the surface of the moon. Lunar luminescence. And he wasn't the only one who saw it. There was a strange thing happening on the moon. And this was a really interesting phenomenon. People actually saw something like a red glow. So William Herschel called it a red glow near the crater, and I hope I'm saying this right, Aristarchus, the Aristarchus crater. And the region of the Aristarchus plateau on the moon has been the site of many reported of these so-called transient lunar phenomenon. So they even have an acronym for it. It happens so often. The TLP or LTP, they actually changed it around sometimes. So this is a short-lived sort of noticeable change or color change of the appearance of the surface of the moon. And this was actually put into an official NASA report. And the region, by the year 2007, so many, many years later, had about 122 such official reports made it. So there were over 122, maybe more. So I'm not aware of one after 2007. And it's really, really interesting. So the events sort of include sort of temporary sort of I would say obfuscation, but I can't say it. Blocking. Don't say long words late at night. Temporary sort of blocking or dimming in the colorations of the surface. And in 1971, an Apollo 15 went about 110 kilometers above the Aristarchus plateau. They actually were detected they detected some particles that might have been due to the decay of radon-222, a radioactive gas. And the Lunar Prospector mission actually confirmed this. So the transient lunar phenomenon is kind of really interesting because it's not volcanic. So originally, of course, back in the 1700s, they thought, there might be active volcanoes on the moon. Now we know that's not the case. But the quote unquote volcanoes, not really volcanoes, but the change in the color of the surface of the moon being noticeable, this can happen in a bunch of different interesting ways. So you get sort of maybe partial outgassing or reflections with off of the crater in the sunlight, things lining up just right, and the luminescent events in the vicinity of a few other lunar features. Tend to be really interesting stuff. So several of the events were observed visually through different telescopes or more independent observers. So we're really reasonably sure that these are real effects, the transient lunar phenomenon. And it's kind of fun because, of course, being a May the 4th, May the 4th overlap, I suppose, with science and science fiction, we get a little bit of, fun, I suppose, astronomy history in action. And the detection of these kind of luminescence events really inspired people all the way from the 1700s up to, of course, write science fiction and want to explore the moon. And now we know that there's lots and lots of interesting stuff on the moon, not just, interesting elements, but also, not just interesting rocky elements, but also now water in some craters, and a lot of reasons to potentially go back there and explore, which relates back to those same Artemis missions we were just talking about. And I for one would love to see a nice walkthrough of the Aristarchus. Sorry, I'm going to say this right this time. I hope the Aristarchus crater. So very, very fun stuff, and it's it actually can get illuminated by Earthshine as well now, because we have so many lights here on Earth. And I believe it's actually still one of the brightest features on the moon. So great for moon gazing.
Mm-hmm. That's really interesting. I didn't know that lunar luminescence was a thing.
It apparently over 200. How many did I say? I had the number here a second ago. By 122 reports, as in official reports, not just not Twitter, official reports by 2007. And there's a great Nature article that I recommend from 1965 on lunar luminescence, where they actually went through and documented everything through 1963, basically all of the luminescences that had been seen so far, and why it probably was not volcanoes. As much fun as it would be to have volcanoes on the moon, it's probably good that we don't.
Yeah, because I feel like volcanoes on the moon would make it a little bit complicated to actually land people on the moon.
Yeah, and if you had volcanoes on the moon, would that mean that you'd have to have had the moon closer to Earth? Because we're really messing with our whole solar system now.
Yeah.
But it seems to me that exploring the moon is something that has always been in the human imagination, and how to get into space and all of the new excitement around different kinds of launch vehicles, different kinds of rockets, all that great stuff coming back up now. It's kind of worth remembering that there were, early excitement led to things like the first that To the Moon movie, the silent film, right? And ideas of what people would find there have changed, but it's still really interesting stuff.
Yeah. Yeah, I'm really excited for of course excited for Artemis 2, but very, very excited for Artemis 3 to actually land on the moon and, go outside and explore some things.
Yeah, and let's make it easier this time. Like let's make it a reliable landing system that any of us can use.
Yep.
Especially me. All right, so shall we go to the next one?
Sure, yeah. So I've got another important piece of history from the space shuttle era, which is May 7th, 1992, the first ever launch of the space shuttle Endeavour. So Endeavour was the fifth and the final space shuttle that NASA had ever built, and it was basically just a replacement space shuttle for the Space Shuttle Challenger that had been destroyed in an accident not long after liftoff in 1986. So Endeavour was just kind of meant to be a replacement shuttle so that a lot of the main mission objectives of the space shuttle program could continue on even after without the Challenger spacecraft. So the name for Endeavour has actually a pretty interesting origin, which is that it was chosen based off of a naming competition that involved a bunch of elementary schools and high schools within the United States. And if I'm remembering correctly, I think this was the first case where NASA did something like this with a naming competition. I think it's actually pretty common now. There have been more than one spacecraft whose names have been chosen based off of naming competitions, but I believe that this was the first one that NASA did. And the rules for the naming competition were basically that those different schools had to pick the name based off of some ship that had sailed sometime in the past and did something significant for humanity or for somebody at the time. So the name for Endeavour was chosen based off of the ship HMS Endeavour, which was a British research ship sailed by James Cook and a crew in the 18th century. But anyways, moving on to its first flight in 1992. The first flight was on what's called STS-49, and it had 7 crew members. There were a lot of really interesting things that happened on STS-49, aside from it being the first ever flight for Endeavour. So first of all, part of the mission involved deploying some satellites out of the cargo bay of Endeavour. But the main goal of this mission was basically a satellite rescue mission. There had been about a year or so prior, Intelsat 6 had launched, but failed to reach its intended orbit. So really the main thing that the crew of STS-49 wanted to accomplish was to reach onto Intelsat 6, grab onto it with the Canadarm, and install what's called a kick motor onto Intelsat 6, so that once it was released and it was at a safe distance, the kick motor would turn on and boost it up to its intended orbit. And the crew did manage to do this successfully, but it did take them a lot of effort. They ended up having to do 3 different spacewalks in order to capture Intelsat 6 with the Canadarm. It was a pretty tricky thing to do, and they kind of had some trouble doing it. So the first 2 spacewalks only involved 2 astronauts, but then by the 3rd spacewalk, they figured that they should add another astronaut to the group of spacewalkers, figuring that that would kind of make things easier and would allow them to actually latch onto the satellite properly. And they were correct. So they did finally manage to get it right on the 3rd try, installed the kick motor, and Intelsat 6 was saved. Later, it was just boosted to its proper orbit. Then finally, after that 3rd spacewalk to deal with Intelsat 6, they did a 4th one, which was to test station assembly methods. So again, this was kind of around the time where the International Space Station was being launched and assembled. So they wanted to kind of test out some of those assembly methods in space before actually using them to assemble the ISS. And it turns out that all of these things were several firsts for space shuttle exploration. So this was the first time that a crew successfully installed a kind of kick motor onto a satellite, so captured it with the Canadarm, installed the motor, and then let it boost itself to the proper orbit. It was also the first mission where there were 4 spacewalks done in a single space shuttle mission, and the first time that 3 people had gone on a spacewalk at the same time. Typically, most space shuttle missions only had 2 spacewalkers per spacewalk, but the 3rd spacewalk that they did in this with 3 crew members, that was definitely a first for space shuttle exploration. So in total, Endeavour flew 25 missions, and a couple interesting highlights from Endeavour's lifetime was it was the space shuttle that was responsible for the first servicing mission of the Hubble Space Telescope. It was docked to the Mir space station, which was a Russian space station. And then it docked to the International Space Station multiple times to do a lot of basically construction and some servicing of the ISS as it was being constructed. And that's actually where most of Endeavour's missions were spent, was helping to construct the ISS. It was even the first space shuttle to really do a lot of servicing with the ISS when it docked 2 of the main modules to the ISS to each other. So it was definitely a very, very important space shuttle, and a lot of great stuff came out of this mission. I was finally retired in 2011 towards the end of the space shuttle program with STS-134, which was the second to last space shuttle mission, where it spent most of its time assembling the International Space Station. And it is currently residing in the California Science Center. So if you were going to go around and try and visit all the Canadarms, you should maybe put this on your list as another interesting thing to go see.
Oh, absolutely. And of course, as you mentioned, with its retirement and the retirement of the entire sort of space launch system for the shuttles, it really was do or die time for a new rocket system to come in because it was, I remember it was a very controversial time because they retired. So this, as you say, the Endeavour, it's using the old Space Launch System, or SLS system, for all the shuttles, and this system was a incredibly successful system that could put 24,000 kilograms or more into low Earth orbit, and it was partly reusable, but it was incredibly expensive. And every time you used the shuttle, it would take a long time to sort of to fix it up afterwards before it could be used again. So they had several shuttles, and by launching them, in stages, they could continuously launch up, and had immense success. But the project cost and the launch cost were so high because they lost so much, even though it was, as I say, partially reusable. I for one found it very, very surprising that they would retire this working system before they had something working to take its place. Mm-hmm. But I'm happy to report that the replacement the replacement shuttle, or replacement system, I should say, for the Artemis missions did work. So Artemis 1 was a success, and of course with Starship, the SpaceX alternative recently exploding, which is one of our news items later because it's come back. But there's still nothing that comes close to that old system in terms of its capability now. But the promise is there. So it's a very, very exciting time, and I really hope we bridge that gap.
Yeah, the space shuttles were also really cool. Like the landing system was awesome.
Yeah. So. Yeah, it was a really interesting system, and it's too bad that it was so prohibitively expensive. Mm-hmm. So over $2 billion per launch, and wow. That's a lot. And you can see why they're just like, it's not sustainable. We've got to develop a new launching system. And for Artemis, it's still pretty expensive, I have to say. But if Spaceship from SpaceX or Starship from SpaceX does end up working at some point, the costs will go down substantially, and that's where it becomes really interesting, because it gets a lot more feasible to put more stuff into space then. Mm-hmm. I just realized, actually, we are about halfway through the show. So this is where I remind everyone that you are, in fact, listening to York Universe, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. If you are interested in joining along with the live OPV chat and asking questions to our crew, or saying hi, you can head on over to our website, yorku.ca/science/observatory, and go to OPV, or click any of the links that say YouTube, and they'll take you right there. So just tonight, you are listening to Dr. Elena Hyde, myself, and Sana Withers, who's here with me. We are discussing rockets in space, I suppose. And we've got one more on the menu still, I think. So yes, I do have one more actual This Week in Space and Astronomy history. It's a little bit different than our previous ones, so I put it kind of at the end. But today is May 1st. And this is the May 1st broadcast. It is, in some places, a holiday, and it's also called May Day. So just as I was talking about May the 4th being a significant day, well, May 1st is perhaps even more significant. So May 1st, throughout human history, as far as we know, has been a significant day. It's often called May Day. It's an ancient spring festival of the Northern Hemisphere, fall festival of the Southern Hemisphere. It's actually an astronomical holiday. It's one of the year's 4 cross-quarter days. That means it's a day that falls more or less halfway between an equinox and a solstice. So in this case, it's between the March equinox and the June solstice. So when I say today in history, going back in time, well, we have back to medieval times documented, and probably well before that. So you'll have to add your own date to this because as you go back throughout history, different holidays have been linked to the May 1st day, approximately. Now, keep in mind that May 1st, this is based on our current Gregorian calendar, which has not always been used as a standard. So astronomically speaking, what we're looking at for the May 1st holiday is actually the cross-quarter day that lies between the equinox and the solstice. Other cross-quarter days tend to be around, sort of February, August, and of course October 31st, which is my favorite one because it's Halloween. Now, when we talked about Halloween, you might not remember all the way from October. One of the things that happens over thousands of years and tens of thousands of years is original alignments can shift. And so although Halloween is on October 31st, the original alignment that inspired it has moved a bit. Because of course of things shift around, and our calendar is not entirely accurate because it doesn't actually use the positions of the stars anymore. So if you use an entirely astronomical calendar, it will always be accurate, but we use now a Gregorian calendar, which makes things a little bit complicated to keep track of. But for all intents and purposes, and for maybe making this a little bit simpler, if we were to just look at the year 2023 Gregorian, the March equinox was on March 20th. The June solstice will be June 21st. The September equinox will be September 23rd, and the December solstice will be December 21st. So if I'm looking for the cross-quarter days, I'm looking for all of the days that go in the middle of those. So what's between March and June? Well, May. So May 1st is approximately the halfway point between the March 20th and June 21st. And because May Day is now linked, sort of pinned to Gregorian May 1st, the astronomical alignments don't always work out with your Gregorian calendar. It also ends up with a couple really fun holidays that have been around for quite a while. Famously, the Gaelic holiday of Beltane, Allan May in Wales, so Northern Hemisphere holidays, very famous for this time of year. The Lay Day in Hawaii, and of course all kinds of other holidays from all over the world that we don't have time to go into in great detail. In particular, the Gregorian calendar and the May Day nomenclature is thought to have been very inspired by Beltane, which is an ancient and medieval holiday, which was a cross-quarter day, marking the beginning of summer. And it definitely feels a lot more summery now than it did in, so if I go March equinox of March 20th, it definitely feels more summery now than it did on March 20th. So I could feel like this is sort of a high springtime, the real start of summer. I can see why it's a significant time of year. And if you are interested in planting crops, in migration of animals, and in all kinds of things that ancient peoples used to be very, very interested in for good reason, the cross-quarter days were really, really useful for tracking them. So it's quite interesting. So quarter days are traditionally sort of thought of in sort of the Northern Hemisphere as, these sort of holidays and festivities. And May Day, you might have heard of the maypole, dancing around the maypole. Well, a lot of that actually comes from these older holidays that were actually linked to the cross-quarter days. And some of them were pretty extreme, shall I say? Maybe extreme astronomy, but it was a pretty serious business, matching up your planting, your crops, and your life to keep your communities alive before we had electricity and all of the modern conveniences, shall I say. There are even some sites linked to the holiday of Beltane from, of course, the May Day that had rather large piles of fires with charred bone for rituals, which is it's like, okay, it's pretty serious, and it goes back quite a ways, as I say, to ancient and medieval times. So you can have a lot of fun diving through the history of even just one of these holidays. So even if you just looked at Beltane or Calland May or Lay Day, you could have a lot of fun with your archaeoastronomy, and that's sort of the history of astronomy through archaeology. There's a famous stone circle in Ireland, the Beltane stone, which is a Bronze Age stone circle, which is linked to the seasons and the cross-quarter days. So that dates from era 2100 to 700 BC. So when I say pick your own date, I mean, I guess pick your best archaeological site and go with that. So this is a very, very ancient astronomy, into this week in history. So the 4 cross-quarter days that divide up the equinoxes and the solstices, the major sections and the 4 quarter days, if you're in the northern hemisphere, your quarter days actually mark the edges of where your solstice is. So if you follow the solstice and the equinox, of course, you've got your longest day, your shortest day, and the equinox being in the middle. Your cross-quarter days would be marked in the middle of those points. So you can find some really fun, I suppose, really fun archaeological tie-ins if you want to. So it's a fun this week in space and astronomy history, looking up at the sun and the moon and marking off your seasons and your cross-quarter days. This is actually the 1st of May. So I just wanted to take this week in space and astronomy and history last fact to say Happy May Day, everyone, and have a good one. It's
there's a lot more history on May 1st than I realized.
Yeah, it's probably too much to cover in in just one little tiny this week in space and astronomy history. You have entire archaeoastronomical papers are written on this, as are all of the cross-quarter days. So the cross-quarter days are more a part of our calendar and our society than I think people often realize. And of course, one of the other cross-quarter days is, Groundhog Day, which we don't think of as a cross-quarter day, but most people have heard of it. And of course, Halloween is a very famous one that's really taken off, and it's still widely celebrated. And of course, if you have your May Day with your maypoles, the wrapping of colorful ribbons on a maypole is a sort of a May Day tradition, and this goes back to at least the Middle Ages, if not before. And this was in the area of the UK and Britain. A lot of early villages had maypoles, which were part of their May Day cross-quarter day celebration. So you had all kinds of things coming in. So astronomy, that's why I say, you can get to anywhere by starting in astronomy. I can get you to any topic, pretty much. You want to talk about ribbons and poles on May Days, well, we can talk astronomy. So it's pretty fun actually. So cross quarter days are the ones, it's just a reminder for our listeners, that's in between. So it's not on the equinox or solstice, it's in between. So you get 4 of them every year.
I did not know what a cross quarter day was until just now.
Oh, well, I'm happy to help.
Yeah.
We will talk about this again on Halloween because it's my favorite one. All right, so let's head over and do a couple little reminders before we go into news. Sana, do you want to start us off?
Sure. So this is just the reminder that the Eta Aquarid meteor shower is peaking this week on May 6th. So if you want to watch the Eta Aquarid meteor shower, it's pretty simple as long as you're willing to stay up kind of late, or alternatively get up very early. You just kind of go outside, get as far away from any lights as possible, and just look up at the sky. For the Eta Aquarid meteor shower, the meteors are coming from the radiant point of Aquarius, hence the name Eta Aquarid, but you should be able to see them anywhere in the sky. So they're supposed to be coming down at a rate this year of about 10 to 20 meteors per hour. And the best time to observe them this time around is just before dusk. So hopefully if you can get away from the light pollution, you should be in for quite a nice show peaking on May 6th. That said, you will be able to see meteors for a couple of weeks on either side. So if the weather on May 6th does not work out, you have not missed your only chance and can definitely see some of the Eta Aquarid meteors this year.
Very true. And that's actually, as some of you, if you've got any kind of astronomy magazines coming in, you might have seen articles at the beginning of the year saying this is the year of meteor showers. And honestly, it's going to be amazing for them, because almost every clear night that I've gone out for observing, I've seen a shooting star. And what is a shooting star but a meteor? And it's because we've just been going from meteor shower to meteor shower. We had the Lyrids in April. We've got the Eta Aquarids in May. Next month, not next month, a few months from now, May, June, July, August, in only two and a half short months, August 12th to 13th, we'll have the Perseids, and the Perseids are supposed to be excellent this year. In October, we have the Draconids and the Orionids, and then of course in November we've got the Leonids. December we've got the Geminids and the Ursids. So we're just getting a lot of really, really good meteor showers, lots of chances to see shooting stars, and maybe you'll get really lucky and a piece will land next to you. There was that giant bolide that came over. I don't know if anyone remembers. It was over Lake Ontario, got caught on the sky cam from the tower, and people were out searching for bits of it. We can always hope.
yeah, that'd be really fun to see a really, really bright one like that. I've only ever seen like more normal meteors. I've seen a couple kind of bright ones, but nothing like light up the sky kind of bright.
Well, and especially if you get a real bolide, you can get some really interesting colors depending on what kind of chemicals you have in it. Greens and reds are very popular, so you can really see something quite spectacular if you're really lucky. I have only seen one really, really, really bright bolide, and it was in 2003. So I have to say they're not very common as far as I can tell. But lots and lots of meteor showers this year. It's a wonderful, wonderful year for meteors. So go out, and if it's clear, just go out and look up. That's my advice.
Hopefully the weather will cooperate for at least one night.
Yes, exactly. So let's go on to some news, because space news has been a bit hopping this week, and I think we've got to talk about JWST because it's just too amazing not to talk about.
Yeah.
So let's do that one first, Sana, and we'll see how far we get.
Okay. Yeah, I will talk about JWST at any opportunity that I get. It's just the best thing ever. So these are some pretty awesome new sets of observations on a very, very distant protocluster that exists in the early universe. So to start off, just explaining what a protocluster is, it's just kind of one of the very early phases in evolution that will eventually produce really massive galaxy clusters, things like the Coma cluster or the galaxy cluster that was imaged in Webb's first deep field. They can have hundreds or sometimes even thousands of galaxies in these galaxy clusters, but of course they all have to start somewhere, and they start out as these kind of small protoclusters that only have like a handful of galaxies in them, but eventually kind of accrete more galaxies and grow into these monsters that we see closer to us than these objects exist. So these observations were in the field called Abell 2744. Abell 2744 is a massive galaxy cluster itself. It's been nicknamed Pandora's cluster because I'm not sure where the Pandora's cluster name comes from, but it's really a gorgeous galaxy cluster. And then this protocluster kind of exists very, very far away in the background of Pandora's cluster. It was originally detected in Hubble Space Telescope imaging. There's really great images of Pandora's cluster from the Hubble Space Telescope in this field. So it was really a natural target for James Webb to kind of complement the data from the Hubble Space Telescope. So it was originally detected in Hubble Space Telescope imaging, then Webb imaged it, got a bunch of new data for galaxies in that cluster, and also got some new spectra of galaxies in this little protocluster. So there have been several different spectra of galaxies in the little protocluster that have been taken with radio telescopes like ALMA or the Very Large Telescope. And then JWST is kind of added onto that with spectra of these objects in the near infrared. And these are pretty important observations because they just kind of augment and they tell you things that the radio observations can't really tell you. So there was this recent paper that they took a lot of those spectra from James Webb and did a more in-depth analysis of a lot of those galaxies that are in that little protocluster that you couldn't do before with the Hubble Space Telescope data or the radio data. So just a couple highlights of the things that have now been learned about this new protocluster from the James Webb spectra is that all of the galaxies in the protocluster are all small galaxies, which are kind of what you expect for the early universe. They're also ramping down their star formation, so they had one big event where they formed a lot of stars, and that's sort of calming down and stopping now. But one of the galaxies in that cluster is pretty old. They also found that they determined the physical scale of this little protocluster, which is only about 60 kiloparsecs, which for reference in terms of galaxy clusters is tiny. They're typically 100 to 1,000 times larger than that 60 kiloparsec scale. So this thing is really kind of a wimpy little tiny protocluster. But the cool thing about this protocluster is that they expect it to grow into a real monster later on in its life. So it'll turn into one of these massive clusters like we see closer to us further in time, like for example the Coma cluster, which is another awesome, really cool cluster. So it's going to eventually evolve into a real monster cluster, which would definitely be cool to observe if we were able to observe it in the future. And while the observations that JWST took, like a lot of these are new things that astronomers have now learned about the protocluster, while the protocluster itself has been known for quite a while, the observations are pretty significant because they can help astronomers study how massive clusters like the Coma cluster form and evolve. It can also help with studying galaxy evolution, how galaxies evolve on their own versus how they evolve in protoclusters environments. And it can also even help to study the gas around those galaxies in the very, very distant universe. So this is a really, really cool set of observations of this little protocluster. And astronomers are kind of hoping that this will only be the first of many cool observations of protoclusters in the distant universe. James Webb, there's always the possibility that JWST can find some more of these clusters. And also coming up in a few years, the Nancy Grace Roman Space Telescope is probably also going to pick up a lot of these things that James Webb can then go follow up with its spectroscopy, which is not something that the Nancy Grace Roman Space Telescope can do as well as James Webb. But for those of you that don't know, the Nancy Grace Roman Space Telescope is going to be awesome. It's basically, the mirror is the same size as the Hubble Space Telescope, which means that it'll be able to get the same resolution as Hubble. But the field of view of this telescope is over 100 times larger than the field of view of the Hubble Space Telescope. So imagine all the stuff that Hubble has been able to do times like 100 with Nancy Grace Roman, which will be very, very fun.
Yeah, incredible wide field instrument. So exciting. And if you've ever done any astrophotography, you know what the advantages of having a wide field camera really are. It's good to have a camera that can zoom in on things, but if you've got wide field and the ability to zoom in, the Nancy Grace Roman Telescope and James Webb Telescope are going to be best friends. That's my prediction.
Oh yeah, I'm so excited for all of the distant galaxy candidates that Nancy Grace Roman is going to pick up, and then James Webb can go and get a spectrum of it. It's going to be fantastic.
Yeah. Yeah, I think there's a lot of us really just sort of, I guess, wiggling on the edge of our seats, waiting. Like, okay, we're ready. Let's go.
Yep.
But yeah, as you mentioned, the new details in Pandora's cluster are amazing, and it's worth mentioning that the massive nature of this cluster, having clusters inside of the cluster, and potentially subgroups inside of that, that's a really amazing thing to be able to resolve. And the ongoing question of how galaxies form and interact, it's just really fun to see it in action. And I highly recommend everyone and go up and look at some of these images. They're really pretty.
The cluster images, I think, are some of my favorites from James Webb. Like they produce so many awesome images, but the clusters are just, it's endless fun in the clusters. You can zoom all the way in and just scroll around and find a bunch of really cool stuff. They're a lot of fun.
Yeah, and as I think that Able 2744 has over 50,000 sources.
Oh wow.
in that image. So yeah, totally worthwhile. All right, we don't have a lot of time left, but I can't let the show go without mentioning the latest thing to hit the news is a little bit of a little bit of a dose of cold water for SpaceX, because we've been talking about the exciting nature of space travel and all of the benefits that we could potentially get out of it. But it's worth noting that this does not come without some controversy, and the FAA has recently sued SpaceX over that Starship launch program after the explosion. So we covered this on the show. The Starship Super Heavy exploded after about 4 minutes, and it threw huge chunks of concrete and sheet metal and material into sensitive environmental habitats. So this was an area that had a lot of endangered animals, some very, very endangered animals. It's an incredibly important area for birds. And the launch and the explosion actually presented a lot of danger to the bird species and the whole area for migratory routes. And the fact that they got a clean bill of health where they had an assessment saying that they didn't think any environmental impact would occur. And I don't have the exact quote, but they basically said, oh, here we go. The FAA concluded significant adverse effects will not occur due to purported mitigation measures. And that did not happen. And so I think it's really worth mentioning that, when we're dealing with especially endangered animals and habitats, we need to keep a little bit of a rein on our rockets, so to speak. If you hear that on the news today, or I guess it's been very, very recent. I just had to put it into the end of the show. It is worth documenting and acknowledging. We need to make sure that where we launch our rockets, they're not going to be causing an environmental hazard. So on that happy note, I suppose it's about time to wrap up the show. But don't launch your rockets into any endangered animal life, and make sure to catch some meteors.
We hope that you've enjoyed this program from AFM Radio.
Those are the two important takeaways of today's show, I think.
Exactly. If you take nothing else away from this show. All right, everyone. We'll go ahead and wrap this up really quickly. You have been listening to York Universe, the astronomy and astrophysics program written and presented by students, faculty, alumni, and friends of York University. The hosts this evening have been Sana Withers and myself, Dr. Elena Hyde. Thanks for tuning in. Clear skies, and have a good night.
Have a good night.
This is Astronomy.fm Radio.
AFM. Broadcasting on 103.2. This is Dublin